Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video, we are covering CCNA Semester 2, Routing and Switching Essentials. This is Chapter 10, DHCP. Section 10.2, Dynamic Host Configuration Protocol v6. Upon completion of this section, you should be able to explain the operation of DHCPv6, configure a stateless DHCPv6 for small to medium-sized business, configure a stateful DHCPv6 for small to medium-sized business, and be able to troubleshoot the DHCP configuration for IPv6 in a switched network. Now, if you configure an IPv6 host address to the client, it's very similar to configuring IPv4 address on the client. All you have to do is go to TCP/IP v6 properties and then select use the following IP address and then type it. Now, configuring IP address manually like this is not scalable at all in a large environment. So we have to use the DHCP server or the client in IPv6 that can assign themselves an IPv6 address. So there are three ways in which a device can obtain an IPv6 global unicast address automatically. First is a stateless address auto configuration, or SLAAC for short, or stateless address auto configuration with DHCPv6. So stateless configuration but with some DHCPv6 options. Or you can have a fully fledged DHCPv6 like we saw it on DHCPv4. The method they use, the method the client will use depends all of a flag is being received from the router. So in router advertisement message, what flag is in there, the client will choose one of them. There's two flags. The first flag is called Managed Address Configuration Flag, M flag, or Other flag, or Other Configuration Flag, or O flag. So we have two flags. Depending on the flag that you receive from the router, you're going to choose one of the three configuration: stateless address auto configuration, stateless with DHCP, or stateful. So when the client sends a router solicitation message, right? That's how the client will start. Where's my router? And once the router receives that, it will send how the client is going to assign an IP address to itself. Should it does it itself using the router's network ID and the client's MAC address, including the FFFE in the middle. So that's SLAAC, Stateless Address Auto Configuration, which means the client has to assign itself an IPv6 address. Now, those flags, both the M flag and the O flag are 0. So managed flag and other flag is 0. If managed flag is 0 and O flag is 1, that means that, okay, well, still assign yourself an IPv6 address using the router's network portion and itself its own MAC address with FFFE in the middle, and ask the DHCP server for a little bit more information. For example, other information the DHCP server can ask is like, what is the IP address, the DNS server, what is our network name, and so on. Or if you just get an M flag one, that means that a router is saying, okay, well, there is a DHCP server in our network, so ask the DHCP server for all the information. So in stateless address auto configuration, the client PC will send a router solicitation message. In that router solicitation, it says, I need a router advertisement from the router. So please tell me what to do. Should I assign myself an IP address, assign myself an IP address and ask the DHCP server for a bit more information, or ask everything from the DHCP server? Now the router advertisement message has M flag 0 and O flag 0, which says, okay, well, assign yourself an IP address. Here's a network address that I can give you, but do assign it yourself, the rest. So the first 64-bit, there will come up the network address from the router, and last 64-bit, the PC will have to assign it itself. Now some devices that will use the MAC address, EUI64, they will use the MAC address and insert in FFFE in the middle, and the 7th bit will be flipped. Some devices like Windows will just choose random 64 bits. After the client has assigned itself an IP address, then it will create an IPv6 global unicast address. After generating my own interface ID, I can use this prefix and prefix length from a router to create my own IPv6 address. So using the prefix the router is generating to create its own IPv6 address, unicast IPv6 address. Before the PC will start using that IP address, it will do something called DAD, duplicated address detection. So it will ping just in case that somebody else has got this IP address. This is called IPv6 solicited node multicast. So it will send this. Are there any other devices on this network using this IPv6 address? Stateless DHCP option is when the client sends a router solicitation and the router advertisement comes back from the router saying, okay, well, you still have to configure yourself an IPv6 address. Here is my prefix that you can use. You can do the network ID yourself, but you can go and ask the DHCP server for a little bit more information. The router advertisement message has some of the addressing information I need, but I need to contact the DHCPv6 server for the other configuration information, such as the DNS server address. Stateful DHCP option is when the receive router advertisement is coming from the router mflag1. The router advertisement message tells me that I need to contact the DHCP server for all my addressing information. So DHCP version 6 operation, for example, you got the mflag1 here. Then the PC will send a solicit message to the server, to all the servers. Then the message from the server will come advertise, unicast, would you like this IP address? And then the client will send request or information. Request is unicast. And then the server will send a reply. So step 3 after the mflag1, step 3 to solicit, find out where is the DHCP servers. Then the DHCP server will advertise the message to you, well, the IP to you and other information. And then you can request and the DHCP server will send a reply. So solicit from the client, advertise, request, and reply. So stateless address auto configuration is a method in which a device can obtain an IPv6 global unicast address without the services of the DHCPv6 server. To configure a router as a stateless DHCPv6 server, so stateless, we don't have a DHCP server, we have a client who's going to create an IPv6 itself with using router's prefix and his own MAC address. EUI64 is called, where he puts FFFE in the middle to make, because the MAC address is 48 bits, to make that to 64, you put those 16 bits, and the 7th bit gets flipped. Configuring router as a stateless DHCPv6 server. So now the router, for example, we still want the client to come up with the IP address itself, but we want to ask the DHCP server for some other information like the DNS and so on. So first we need to enable IPv6 unicast routing on our DHCP server. Then say IPv6 DHCP pool. So we create a pool. It's up to you what name you give to the pool. And then we go inside DHCPv6 configuration mode, and in there we want this. The only thing very important, we need to define the server. Where is it, our DNS server? We can do a domain name as well, other options we can write in there, but pretty much you do need a DNS server. And then we go to the interface G01 and we bind that. So after we give an IPv6 address, we bind this interface to this pool that we gave. So IPv6 DHCP server IPv6 -stateless. Stateless means that the router, even though it's giving you some information, it really is not keeping track of pretty much anything. The client asks for the information, the server, the DHCP server says, okay, here's our DNS server, here's our domain name, but it's not keeping track who has he told about this information. And to do this stateless configuration, there is one command very important, and it's on red here. It says IPv6 ND or neighbor discovery other -config -flag, which means that O flag has to be set to 1. M flag is 0, but O flag is set to 1. So when we do IP interface G01 on router 3, that's our client, we say IPv6 enable, and then we say IPv6 address autoconfig. Autoconfig is going to auto generate an IPv6 address, but it's going to ask for some more information from the DHCP server, like the DNS server. When we go to that DHCP version 6 server, so we say show IPv6 DHCP pool, we can see the active client is 0. So it's not keeping track of whatever information is giving it out. So verify the stateless DHCP client using the following command: show IPv6 interface or debug IPv6 DHCP detail. If you want to configure a router as a stateful DHCP version 6 server, this is fully fledged DHCP server. So first, again, we need to enable the unicast routing because it's not enabled by default. Then we have create a pool, whatever pool you want to name, IPv6 space DHCP space pool, and then name the pool. And then we are inside IPv6 configuration or DHCPv6 configuration mode. Then we need to tell what network, what prefix are we on. So address prefix 2001 DB8 CAF1://64 lifetime infinite. Then we have to configure our DNS server IP address. We have to configure, for example, our domain name. And then we have to go to the interface and enable or bind this DHCP pool to that interface. So IP DHCP server IPv6 stateful. And the other command that is very important, now we say in the neighbor discovery, is managed -config flag. So we're gonna keep track of all the information because all the IP addresses that we are giving out. So for example, the prefix here that we have, the first address will be on that network. So interface G01 IPv6 enable, so we enabled it on IPv6 on that interface. And then we say IPv6 address DHCP. So the client will actually ask the DHCP for the IPv6 address. To verify it, verify the stateful DHCP server using the following commands: show IP DHCP pool and show IPv6 DHCP binding. Verify the stateful DHCPv6 client using show IPv6 interface command. So when we do show IPv6 interface G01, we can see the IPv6 is enabled and we can see the IPv6 address that we have received. To configure an IP router as a stateful DHCP relay agent, because it's the same, the messages are not going to go, the solicit message to the DHCP server, they're not going to go to if the DHCP server is not in our local area network, we have to configure this relay agent. So for example, that DHCPv6 server is down here. The solicit message, they're never going to go to that destination. So we type the command, we go to the interface where we hear the solicit message, IP DHCP relay destination, and then the destination of DHCPv6 server. Show IPv6 DHCP interface G00, we can see the relay destination where we can relay these messages. Verifying the router DHCPv6 configuration. So here on the top we can see that it's stateful configuration there. We create a pool, we give a prefix, domain name, DNS server, and in the interface we say IPv6 ND neighbor discovery. This time is managed flag because it's stateful. In stateless we don't put the address prefix because we let the client to actually generate their own IPv6 address, and we say IPv6 neighbor discovery other. We can do debug IPv6 DHCP detail, and we can see that all the solicited messages, they come in from the client towards the server. Then other messages we're going to see is advertise, then request, and others maybe reply, and so on. Thank you very much for watching my video, and please have a look at other videos, and don't forget to subscribe. This has been Astrid Krasniqi, and bye bye.